thing we said about number 8 was, or about Euler's method, is assumes that the slope stays constant for the whole step. When in reality it probably doesn't. Well, number 8 it does. Number 8 is y prime equals 3. So it's going to stay constant the whole step. It's going to be 3 the whole step. So it should fit perfectly. It should be, Euler's method should give you exactly what the graph or the thing would be. All right, so 11, 13, 15, those are just basic Euler method ones. Do you want to review? Do you want to go through that at all? Which one?
15. Oh, I just had a question about step size. Is that like delta x is always just step size?
Yes. So if you're given an initial condition, well, you want to do 15. Okay, so 15 says IVP is y prime equals y squared. Okay. And it says y of 0 equals 1. So, yes, Skyler, so if y of 0 equals 1, and then they're always going to ask you to find something else. Well, in this case, they want you to find y of 0.8, right? So there is your A and your B, right? So you're wanting to go from 0.8 to 0 to 0.8, and you're going to do it in how many steps? 4 steps. Now, notice they said 4 steps of 0.2. They wouldn't have had to say that. They could have just said 4 steps. You could have calculated the 0.2, right? So maybe they give it to you, maybe they don't. Now, what I would do is I would go right in here and put 0.2, 0.4, 0.6, and 0.8, right? I would go right in there and fill that in, okay? And then, okay, so here we go. So what's y? Well, they gave us the original starting point is y of 0 is 1. So how do we get y prime? We're going to put a 1 in here, right? And so that's going to be 1. And then how do you get delta y? You take y prime times delta y, delta x, excuse me. Okay, so y prime, so 1 times 0.2 is 0.2. Okay, the new y is y, the old y, plus delta y. Right, so we just got to know what these things stand for. So 1.2. Okay, so 1.2 is right here. So what's the y prime? 1.2 squared, so that's 1.44. Right, and now 1.44 times 0.2? 0.288. And I knew y is 1.2 plus that, so what's that? 1.488. Okay, and then this is 1.488. Okay, and then we take that and square it. Does anybody else have these numbers? Jesse, you have these numbers?
Did you end up at 24.016?
So what do you have right here? 2 point what here, Emily? 2.214. And then y prime times 0.2. 0.443. Now you're starting to round, right? But you want to keep those decimals in your calculator. That's the key, right? You don't want to use 0.443 now. You want to use those other decimals. Okay, what do you got now? 931. Jesse, keep agreeing. And so 1.931. Then what's here? 3.728. 0.746. How much? That's where you're on. Because it should just be the old y plus the new one. So you must have added these two. Because that, you said 4 point what?
47.
Yeah, that would be these two. It's the old y plus the new one. So Jesse, what'd you have there?
2.67.
And that's actually it, isn't it? You're done. So it's just your last number you were off. See, because now you're done. Because that's x and y. What'd you say before? I thought you said, or you had looked it up and you said 2 point.
Yeah, it said that.
So it said 2.675. So you were all good until you just added the wrong numbers.
Can we do more calculator ones?
Yeah. Okay. So
I think 11. That's 11.
11B, if you had to do 10 steps, it was. 13A and B were both calculator ones. Now, here's something that the other class showed me. I thought about this, but I hadn't done it before, or I have done it, but then I guess I forgot about it. I don't know. But we tried it. Somebody mentioned it in the other class. We tried it, and it worked fine. So if you go, so let's put it in here. So let's do 11. And so you go to your menu, go to your graph entry, go to your differential equation. Now here's what we decided, because people always have trouble remembering to do this y1 part of this right here, right? Well, you don't have to. You can actually change this. If you want to do p prime, if you want to do your differential equation as p, you can put p in here, right, for the problem. Now what you can't do is change the x. It's got to be x here, okay? So in this one, it's 1 plus, so this is 11, right? 1 plus t minus y. But what you can do is delete that 1, and it works. So we tried that in the other class, and they were working it, and it was all working good. You notice how it changed this y now to a y1? But I don't think there's any way to change your input variable to a t.
We talked about this last time.
Differential equation. Yeah. So, but I think you have to keep it an x as your input. I don't think there's any way to change that. Okay? Like if we typed in right now 1 plus t, it doesn't change that. So we can't do it. It's going to treat that as a constant. So we're going to have to do 1 plus x minus y. Okay? So if you want to do that, you can, but you got to remember to change it over here. If you have y1 here, then you have to have y1 over here. Okay? All right, and then your initial condition is 0, 1, so you can't forget about that. There are 3 things you have to do. 1 is put in the differential equation correctly. 2 is put in the initial condition correctly. And then 3 is the plot step, okay? And that's these 3 dots. Whoops. Now notice, since I changed that, since I deleted that y1 off of there, it made the next one y1, because this is actually differential equation 2 right here. So I need to arrow up. It looks like it disappeared. The first time I did this, I thought it had disappeared. I got to arrow back up, and that's this one. So I need to come over here and edit that right there. And I need to come down here, and what's my step size on this one? On 11, I'm going to do 10 steps of 0.2, because we're trying to find y of 2. Now, we could have calculated ourselves 2 minus 0 divided by 10, but it's 0.2, so we got to put in 0.2. 0.2. So those are the 3 things you've got to do. Now you might need to set your window also. Okay, you might need to set your window. All right. It's not a bad idea to try a Zoom standard just to begin with. Just do a Zoom standard if you want something to start with. And now what do we need to do?
Trace.
Now we just trace to 2. And you can just go, and it should be going by 0.2, right? Or I can just type in a 2, right there, 2.107. Okay, so on the quiz, that's all you would write. If it said use 10 steps to find y of 2, you would just say y of 2 is, you probably should say approximately 2.107, okay, like that. That's all you'll have to put. You won't have to write anything else. Okay, but you got to be able to get it over your calculator. And then in 11C, show that the exact solution is this. That's a T chart. And then once you've shown that is the solution, then you can plug a 2 into that. Now you can plug a 2 into that and actually then compare it to these answers here. Right? That'd be the equivalent of being able to do the antiderivative, find the exact area, and compare it to your trapezoid approximation or your Simpsons or whatever. Okay? And we're going to review those things here a little bit, but we're going to do something else here first. Okay? So is there anything else on Euler's method? I mean, those are the basic things you got. I mean, you need to understand, be able to answer a question about how it works, whatever, but you're going to have to be able to create the table. You're going to have to be able to do 4 steps, 6 steps, 8 steps, whatever. If it's 10 or more, go to your calculator and trace.
We have to do like 13C.
equals
Show
13C.
the exact solution of IVP.
That's what I was just talking about. Yeah, that's what I just said. Yeah, that's that T chart. You want to do that?
Yep.
13C. So the differential equation of 13 is y prime equals y minus 2.
What does IVP stand for?
What's IVP stand for? Initial value problem. What is an IVP? It's a differential equation plus an initial condition. Okay. So it says solve the IVP, it's really saying solve the differential equation, right? Solve the differential equation means find the original solution, right? The difference is when it's an IVP, you have an initial condition, so you can plug it in, you can find the C back. That's the difference. Okay? So show that the exact solution is y equals 2 minus e to the t. So y equals 2 minus e to the t is what they're telling us the solution is. So I can put that right here, 2 minus e to the t, e to the t minus 2. The 2's cancel. I get negative e to the t. Up here we can do y prime. Y prime is, that goes away. This would be negative e to the t. So I can put that over here. In place of y prime, negative e to the t. Check. You still tired from calling me? Because I'm pretty sure I just said that. We gotta be able to do that teacher. That's all. We have to do that. So 13C, and then 11C is the same thing. 15B is the same thing, right? Yes. Show that it is a solution. Now, I actually left off a part though. What did I say yesterday? You also have to show when it's an IVP. You have to show that the initial condition works. So you have to put in y of, in this case, what was 13C was y of 0 equals 1. So I have to put a 0 into there. 2 minus e to the 0 would be 2 minus 1, which would equal 1. So check. So put in a 0, and you do get a 1. So that is, that checks as well. Okay, so when it's an initial value problem, it throws in that initial condition. So you got to bring that in. Okay. And on 8, we could solve it ourselves. On 8, it was y prime equals 3, so we can just solve that ourselves. That's 3x plus c. Then we can put our initial condition in, and we can find the c back. Okay. And I can't remember if it told you to do that. Yeah, it was first saying find the exact solution, right? And so that's how you do. So that's the solution. That's the general solution, and then you put in your initial condition, find the c back. Okay. All right, just some differential equation stuff. All right, anything else? Anything else? Don't be afraid to ask. I won't make fun of you. Right? Don't be afraid to ask. All right, so I gave you that 2014 package. We're going to spend a little time here looking at a few review problems. Then we're going to come back and we'll spend the last part of it reviewing. Just talk about the quiz in general and just giving you a few extra problems you can work on.
Is that all calculated?
Yeah, I think so. I think it's all calculated because it's obvious the ones you have to write out, right? Like if I tell you to do a T4 approximation, a 4 trapezoid approximation, you're going to write out a 4 trapezoid approximation, right? If it's a T10, well, I'm not going to ask you that because you'd have to use that calculator program, and I don't think when we're in test mode we can use that calculator program. So that's a non-factor, so I won't ask you that. But, so you're going to have, and we're going to review that here a little bit, like an L6 or whatever, you would write that out. But then you use your calculator to add them up, right? Add up the different parts, but you're going to write that out. Same thing here. If you're doing Euler's method with 4 steps, 6 steps, you're going to write that out, but you can use your calculator to get the different entries in the table. So you need the calculator for those things. All right. So let's go to number 1. Number 1 on this packet, right here. Go ahead and take 5-10 minutes here. This is a calculator one. To work through as much of that as you can. And you can talk to each other if you want to help each other out.
Jesse, yep. Did you get it? Maybe.
So I don't know. I don't remember this.
What did you do? Derivative. Is that what I have to use? Oh, okay, that was average rate of change. Yeah. So you do we do the derivative against the rate of change.
Max, you put 30 in for t, and you get that value, and then you put 0 in for t, and then you do
Oh, yeah.
the
30 minus. I did
value of 30 minus value of 0.
Yeah, 30 minus. Or I did this.
Did you get? Yeah.
Negative 0.96. Procedures.
Don't you do a solve? You set it equal to
Set what equal to what?
first you have to find the average amount of grass clippings in the bin.
which is, that's not confused.
Yeah. Cause A is the average rate of change.
A is what?
Average rate of change.
Oh, part A. Part A was average rating. Right, okay. I thought you meant function A.
Wait, is it like the average amount of the integral of, like,
Bing, 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 bing,
it's
bing,
like the
bing, bing.
integrals of it
Yeah, you
over
can just
B
do-
minus A? So it's the integral of the A of t
From 0 to
over 30 minus 0. Did you guys get for the average amount? 7.3. So then you have to set. You put it equal to that.
do the sum. 14.
Yeah. Is that what you got, Jesse? Did you guys get 12.413?
12.415.
5?
I use the exact.
Yeah, so.
You got,
I just used the rounded answer. I changed it.
oh, somewhere along the line this year I should have mentioned something about never use the rounded answer.
Should come in my chemistry class and tell them that, because we get in a heated discussion every time I don't use the rounded answer. They round it like 2 sig figs. It's just terrible. 8 decimal places.
You're not supposed to round a sig figs to the end.
Yeah, they're off like 4 or 5, and they like get mad at me and they go, I'm sorry, I'm right.
Yeah, well, yeah. But even then, when you're using sig figs, right, you're not
You just round it at the end.
round at the end,
Just
right?
keep everything in your calculator.
Right.
It's so weird how there's like.
Now, you can set that, like, so this has, so that's a nice thing about float. Like, you can do float 2. If your problem has 2 sig figs, you can do float 2. And it'll only shoot 2. So if your answer's in the hundreds,
do that on the whole you can do that on this
on those 2, yeah. But it'll keep all of them behind the scenes. That's the thing. If you're in float 2 and you're doing those calculations, you're only seeing those 2 significant ones, but it's keeping all the digits in behind the scenes. So if you keep using those numbers from your calculator, not typing them in, you know, if your calculator shows 320, the 3 and the 2 are this. If you're in float 2, it'll only show 320, but it might be 318 point something something something. But it's rounded, it's rounded it to those 2 sig figs. But if you type in 320, then it's using 320. You know what I mean? So that's the thing. You gotta be careful. Okay, let's talk about it here. What'd you get? So through C, that's good, and I agree with what you guys had. And we can do D later. So we're talking about. So those numbers sounded good. Notice the rounding. We said you don't have to round properly. So if you had negative point, this is the actual points that were allotted that year for these problems. So like you said, now it said show, I don't know if it said show work in part A. Looks like they only gave one point. You had to have the answer, you had to have pounds per day. Okay, now either one of those were okay. And then down here, I heard you guys saying 163, 164, which is fine. And so you didn't have to have units there, but then you did have to write this out, right? It's the amount of grass clippings in the bin is decreasing, or the grass clippings are decreasing at a rate of pounds per day. Notice they didn't put a negative on there. If you're going to say decreasing, don't put a negative. If you're going to say,
What if you said decomposing?
yeah, did you put a negative on these numbers?
Well, then I wasn't sure because decomposing basically means you're taking.
Yeah, I think anytime you're talking about a rate, I would use the words increasing and decreasing. I would always use the words increasing and decreasing. So the amount is increasing or decreasing. Now, if you want to say changing, then you would put a negative on there. So you'd want to say if the rate is changing at a rate, but I think the best answer is this right here, decreasing. And notice they said at time 15 days, so you need to get the at, the instantaneous part of that.
Or could you say on the 15th day?
On the 15th day, decreasing at. Something that showed at, that it was instantaneous. And then here's what you guys were saying. So again, showing your work. It didn't really say that in here, but that is a given. You should always be showing your computation stuff. Notice they gave 1 point for seeing that you used average value here. So even though you could just go to your calculator and get that calculation, they want to see that you did average value. So you should always be writing this stuff out. And then notice, like you said, then you set your A equation equal that. Now, the other reason, Max, you should know that, remember what average value is. Average value of F uses F in the formula. So since they wanted the average amount of grass clippings, the average amount of grass clippings, A is the amount of grass clippings, right? So that's why it's the integral of A. You want the integral of the amount of grass clippings if you want your answer to be the average amount of grass clippings, because it's in pounds. So A is in pounds, so the units on this would actually be pound days, right? The units on A is pounds, the dt is days. This integral would be pound days, but then what's the 1/30? That's 1 over days. So pound days divided by days, that gives you pounds. So that's why that's in pounds. And then you go ahead and set that equal and do a solve. Make sure you have that as well. You need to have A of t equals whatever that number was. And then you get this. And notice 413 would not have been good enough. 413 would not have been accurate to 3 decimal places. So you'd have lost that answer. Okay, let's go to the last 10 minutes here before we do our review stuff. Let's go to number 4. And I want you to do part C. Think about your units, okay, what we've talked about with integrals and so forth.
you supposed to know velocity?
That's the table. Table's velocity. You got some?
Yeah, I guess I'm the right values.
Well, what do you got?
Add negative 15.
What'd you get? Where'd you get negative? How'd you get it? What do you guys do?
Wrote the integral.
What was your integral?
F paired broken to as well with negative 150x plus 600.
Where'd you get negative 150x plus 600?
Well, it tells you that you're writing position at T12, so I used the
Yeah, but see, that assumes it stays at velocity the whole time.
I used the initial condition to 300.
Is that, Jesse, is that what you were doing?
I did trapezoid.
So how'd you do trapezoids?
Well, I did trapezoids after.
Right. You should write the integral first, to be honest with you. Did you write an integral, Jesse? Here, there's a reason they said that, because this is something I said earlier, and this is why I want to do this again. I want to reiterate this. Because sometimes they don't have that sentence in there that says write an expression involving an integral. Because this could be on the quiz tomorrow. We've talked about this enough, and this fits in with what we're talking about with trapezoids and rectangles and stuff like this, and we got to know it on the final. But that sentence where it says write an expression involving an integral that gives the position of the train at time 12, that's actually helping. That's a helping statement for you. A lot of times they just say use a trapezoidal sum with 3 subintervals indicated by the table to approximate the position of the train at t equals 12. Remember, a trapezoidal sum is an approximation to what? An integral. An integral. A left rectangle, a right rectangle, a trapezoid of Simpson's is an approximation to an integral. So until you write an integral, you really don't know what it is you should be writing this trapezoid sum for. Now, I don't know how you got 315. If you you should only go from 2 to 12, right? I agree with you. It should only go from 2 to 12 because that's your initial condition, so we shouldn't be using the 0, 0. So how are you getting 315?
Do you have to find the average?
350. Well, tell me what your trapezoids would be. Can we do that shortcut that we learned in this chapter? Where we have the b minus a over n pulled out? Is that what you did? Yeah, we can't do the thing plus 2 plus 2 plus 2 like trapezoid, right? Why not? They're not the same width. This one's 3, this one's 3, this one's 4.
What do you have for answer? Like, is it bigger or smaller compared to what we have?
Well, and then how did you use the 300? So when you did your trapezoid, so what'd you say, 315? Did you guys get the same thing?
I got 315.
What'd you get, Will? Did you?
Negative 450.
Negative what?
450.
Okay, negative 450. So let me show you.
Wait, I think I know what I did now.
Okay, so let's talk about this. This should be the easy part, right? You guys are making it too hard because.
That's what I got.
Okay, good.
Now that's meters per minute. So V is meters per minute, right? So this would be meters. So this would be the position from, right? Now sometimes they ask you, they'll say, write S of T. Now S is what we use for position. Like you could use P, you could use whatever. They didn't give any names. You could use P for position or whatever. Doesn't matter. S a lot of times is position. But so whatever you call it, doesn't matter. But S of T, well, we have to be careful here. If we want to do S of T, then we could have done this. Now think about this a minute. If I had done S of T, if they wanted just an expression for the position at any time, right? We could have done S of T, and then this interval could have went from 2 to T. But if I went from 2 to T, if I'd used T up here, couldn't use it in here. I'd had to use something else, right? But we just wanted the position at 12. So S of 12 be the interval from 2 to 12 of V. Now, let's remember, what did we talk about though? This is the rate of change of the, what is it, train. This is the rate of change of the train. So what's the integral represent then?
Distance.
Net
Distance.
amount of change. Net distance traveled, right? So this integral, V is the rate of change. This integral is the net amount of change. The net distance traveled. Okay, so just keep that in the back of our minds then. That's the net distance traveled. Is that the position? Is that where it's at 12? No. What are we forgetting about? What are we forgetting about? Because they want the position. They want an expression involving an integral that is the position at 12. So this is not right yet. What do you have to do with the initial condition? Huh? Now you're making it too hard. What do we do with the initial condition? Add it on. Listen, yeah, if S is the antiderivative of this, right? Then doesn't this represent, technically, isn't this S of 12 minus S of 2? Wouldn't that be the integral from 2 to 12, right? So if we want to know what S of 12 is, what do we need to do? Doesn't that have to add over to there? So isn't this plus the initial condition? Isn't this plus 300? Shouldn't this be plus S of 2, right? Yeah, now a lot of times you see it written before. You'll see 300 plus. Because remember, that's the net amount of change. So we want to add that on to where we started. So the right answer, so you got 1 point for this in this problem. You got 1 point for having this. So keep in mind you have to add, just like this, if you're pouring water into a tank, if you find the net amount of water that went into the tank from 2 to 12 hours, and that, let's say this was a 10-hour period, we were pouring water into a tank at this rate, then from 2 to 12, the integral would say how much water we put in. But how much water's in the tank, what do you have to do? You have to take that amount that you put in and do what? Add on how much you started with, right? I mean, the amount you put into the tank has to add on to what was already there. Well, that's the same thing. This is the net amount of distance we traveled. We have to add that on to what we already had traveled. You have to add on the 300. Okay, well so I agree with you, Will, on the negative 450, right? Here's what your trapezoids would look like. 1/2, 100 plus 40 times the width of 3. Then 1/2, 40, and the negative 120 times the width of 3, and then 1/2, negative 120, negative 150 times the width of 4, right? These are your 3 trapezoids. So we can't do those shortcuts that we're going to talk about here in a second, right? So that means what? What did this train do over those 10 hours? It went back west. So it went back past this, well, yeah, we can get to that in a second, but it went back west. Over those 10 hours, it ended up going west 450 miles. Now, we know it looks like it went east for a while, and then it went back to the west, right? But it ended up a net west distance of negative 450. Now, where it had started, it had started 300 east, but it went a net of 450 west, so it ended up, so here's the points on this problem. You got 1 point if you had that on your paper. You got 1 point for that work. And then you got 1 point for the answer of negative 150 meters. Now, it would be good to explain. It didn't say to explain it. It said use a trapezoidal sum to approximate the position of the train. So negative 150 meters would be okay, or you could say 150 meters west of the station. The position at 12 is 150 meters west of the station. Okay, so we got a little work to do to get that, but that should be, we should be able to do that. That's right in what we're talking about. But again, the more we're exposed to it, by the time we get to late April, and we start getting ready for our finals and start getting close to the test, we'll hopefully see some more of these. But we're looking at those units and the net, the things we've talked about with net. We have this table and we do the trapezoids and what does it stand for and so forth. Okay, let's talk about your quiz here. And so, if you want to have your calculators out, we can hash over a couple things and make sure you're ready to go on that. But so if we look at, of course, these were our shortcuts. But again, that, as we just saw, that only works for equal width, right? So I don't care if I want you to do 4 left rectangles. If you want to write out the 4 left rectangles, height, width, height, width, height, width, that's fine. But if we're going to do a integral from 1 to 3, and you want to do 4 left rectangles, then you can go 3 minus 1 over 4, and then you can go f of 1 and f of 1.5, because, right, the width would be 0.5, and f of 2, and f of 2.5, right? You're going to stop short of the right edge, and you can write that out, and then whatever your function happens to be, you can plug those in, and there you go, right? That's one way you can do it left. But if you want to say f of 1 times 0.5, f of 1.5 times 0.5, f of 2 times 0.5, and f of 2.5 times 0.5, whatever, I don't care. Midpoint, same thing. The trapezoid, this is kind of a shortcut. Don't forget the 2n under there, b minus a over 2n. And you got this with the 2-2-2 pattern. We were just talking about that. And then Simpson, don't forget that that's 3n. This will always be even. I won't try to trick you. There will always be one more. So if you're doing a T8 or an S8, there'll be 9 of these in here because you're using both the left edge and the right edge on those. Of course, in the midpoint, you only have that many. On the right edge, you don't use the left. On a right rectangle, you don't use the left edge. You go all the way to the end. And like the left, we saw you use the left end, but you don't go all the way to the right. Okay, so be able to write those out, be able to calculate those. Of course, also you can remember that you can use this for trapezoid. So if you've already done an L3 and an R3, you can just average those to get your T3, right? If you want to do that, or if you just want to write out your T3, that's fine. If you want to do an S8, for example, you can do 2 M4s plus a T4 divided by 3, or you could write it out like we have in this picture. Okay, and of course, all these come from some integral that you're given to start with. Okay, and then we talked about over and under estimates. So when a graph's increasing, rights are over, lefts are under, and vice versa. And we talked about midpoints and trapezoids kind of go together. It's the concavity, so concave down, a midpoint's going to be over. Concave up, a midpoint's going to be under, because a midpoint's like a trapezoid that's tangent. So it's like a tangent trapezoid, whereas an actual trapezoid goes from the endpoints. So a trapezoid would be over on this case, and a trapezoid would be under on this case. Okay. Then we talked about those error bounds. So this is the actual amount of error. This is the exact area right here. This is your approximation. You subtract those. That's how much you're off. This number over here would be your max error, because this says your amount of error is less than or equal to that. That's called an error bound. And then we had our formulas. Make sure you memorize these, okay? I may give them to you, okay? I may give them to you, but, I'm probably going to give them to you, okay? I'm going to give them to you, okay? What did I say before? Did I say it?
Yeah, you said
I said on my, yeah, you see, yeah, you did. I think I played it. Yeah. Okay, I'll give those to you. You've got to know what K1 is, though. K1 is a max of F prime. K2 is a max of F double prime. Know when to use them. right? Understand that midpoint, but I'll give it to you, but midpoint trapezoid, you're using K2 because it's a concavity, so we need the F double prime. That determines the error. Here it's the slope that determines the error, so use K1. So it's the max, and we can do a quick problem here and
Which is the,
remind you to
if
do
you go back a slide, that's what was in that box.
That's what'll go in that box
Take
right
the
there.
actual minus whatever you did, and that's.
Right, so if they want to find an error bound for this trapezoid, we would for trapezoid, we use this formula right here. Right. So then if they give you a problem where they say, okay, find how many rectangles would it take to have for this, right? And then that's where you would just set that equal to that. And that way then you would find how many rectangles, right?
Wait. Put the 0.005 in for the K.
No. 0.05 would be all of that.
That would be equal to it, but what would your K be?
You have to find that. You have to find that because because you're given an integral. You'll be given an integral here where you're doing that. So K is the max of F double prime. So you got to graph F double prime, do the bars around it, find the max, round it up. You got to go through all that. You got to be able to do that.
Will you be able to get with us just doing like a solve error?
What do you mean a solve?
Like setting that equal to the 0.00.
Oh, right. So then if you have, so what I'll be looking for is your K2, whatever number goes in there, and then you'd have like 3 minus 1 cubed over 12n squared less than or equal to 0.005. You have that set up, right? I'm going to be looking for that. I want to see what number's in here. But then at that point, you just solve and you get n less than or equal to 27.431. Well, so how many rectangles does it take? Oh, actually, that'd be greater than that, less than. So it would take 28 rectangles or trapezoids in this case. We're doing trapezoids. But you can just type that in your calculator and do a solve, right? Just like we did on the whole one. Yep, just like we did on the whole one. Okay, so that's pretty much it. So what's the quiz? So left, right, midpoint, trapezoid, draw, write out, calculate when n is less than 10. So if you're doing, single digits, we're writing them out. Kind of thing, be able to answer questions about over, under approximation, that kind of thing, just like we did on those true, false ones. The max error formulas that we just talked about, K1 and K2, that kind of stuff, be able to use those. And then all the stuff we just talked about in the homework. Less than 10 steps, we're writing it out. Greater than or equal to 10 steps, we just trace on our calculator, just like we were talking about today. Okay? So those are the main ideas, but then don't forget, just like that story prop we just did from the AP test, being able to use this stuff, being able to do a trapezoid approximation that means something, that has some meaning in a problem, is something we want to be able to do as well. And it's not something you really study for, other than I just exposed you to it again, but just be able to understand that if you set up an integral that represents some value, that you can use one of these approximations to do that integral. Maybe it's an average value problem, right? Maybe you set up an average value integral and then you use, trapezoids or something to do that integral, and then you divide by the 30, like that one we did, 30 minus 0, right? So these all approximate an integral. Remember that. Okay? That's it. So here's some problems, but let's just, before we do that, let's go back to our calculator. So let's say we had an integral. So let's say we wanted to do, we wanted to find the error bound for, let's say, T8 for this integral. So let's say we were going 0 to 5. Let's say it was, we'll do something simple. Say we were doing that right there. We want to do the error bound for T8, right? So T8 would be K2. So you have K2. You'd have 5 minus 0 cubed. And then what was it? 12 n squared, right? So we need to find, so we want to know what the error bound is for that. So we're gonna go to our calculator. We're gonna get rid of this, Oilers. Probably don't need to get rid of it, but actually the fastest way is just to go up here and clear the scratch pad from it. Just clear the scratch pad. Okay, and so we're gonna graph what? We need the second derivative of that guy. So one of the ways we said the fast way to do that is to go over here to do the second derivative, because this is our trapezoid one, so we need K2. And so I got x cubed minus sine x got my second derivative. I'm going to copy that, go into my calculator screen, paste that. Then what do you say to do? Switch my window to 0 to 5.
Do you have to put in absolute value?
Typically I do, yes. I should have done that. Thank you. Good idea. Now, as long as you understand though, what if you don't do absolute value?
You just have to go
You have
down.
negative values.
Oops. Can I do Control Z? Did we ever decide to, is there an undo on this?
It's silence.
And I want to do absolute value. But you just have to look, if you forget the absolute value, you're just going to have to, if it goes positive and negative, whichever one is biggest, right? I mean, you want the biggest, but yeah, it'd be better to do absolute value, I agree. Okay, now go to our window. Let's go Windows 7, 0, 5. Let's do a zoom fit. And we can tell that the max seems to be out at the right edge, right? So in this case, we trace. Usually we would just trace until it said max, but now we can tell it looks like that max is going to be out there at 5. 29.041. So what do you think would be a good number to use? 04 what?
04 or 042.
It better be 042, right? We wouldn't do 29.04. But see, but you guys are stuck on the 3 decimal place thing. Now, if you do 29.042, I'm fine with that. Okay? But actually, 29.1 would probably be fine. I mean, 29 is a pretty big number, right? I mean, if you go 29.1, you haven't changed this number that much. But if you do 29.042, I'm fine with that. But you don't always have to go 3 decimal places, and there might be a time 3 wouldn't be good enough. Because if you got 0.04067, would you go 0.005 there? 0.005 would not be very good there. I think you'd go at least 0.0041 and maybe 0.00407, right? So don't get too stuck on 3 decimal places when you're doing this K1, K2 thing. I think 29.1 would be fine. I think 29.05 would be fine.
How did you know to choose?
Well, we want the max. Because K1 and K2 is the max. So when you look at it from 0 to 5, you want the highest point. You want the highest Y value. Well, this was just going up, up, up. So I could tell it was at the end. It was 5. But otherwise, you're looking for the maximum. So if there's a peak, then you want that, right? So we just want the highest point. So what do you want to do? You want 29.042? I don't care. That's fine. Okay? So you want to do 29.042. Okay? And then we just calculate that out. So we just calculate that out.
It's not giving me decimals, it's just giving me 29.
Well, because, okay, so you're okay, we talked about this the other day. Now your window, you got to change your window float on both screens, on your calculator screen and on this screen. Now when we get to the quiz, if that's happened, see that seems to say float. So go to your menu on your graph screen, if you're on your graph screen right now.
Yeah.
Go to menu, and it probably says float 3. We change it to float.
Let's change
Okay.
that to dock.
Well, and in doc, you change it, that'll change it on your calculator screen. But on this screen, you want that. Okay, so now on the calculator side, we would just type in our 29.0442 times 5 cubed divided by, make sure we get some parentheses on that, and then 12 times 8 squared. Okay? Is that what you guys are getting? But look at that K value. Right? I mean, that's not much of an error bound. That's telling us that our 8 trapezoids are going to be.
Unless you're replacing that.
What, say that again?
Aren't you, it's not less than or greater than that, isn't it? That's by equals.
Well, no, because remember, we're rounding. What we're saying is, yeah, you're right. I mean, what I'm saying is I minus T8 is less than or equal to this, which means it's less than or equal to this. That's what I'm saying. Okay, so I minus T8 this is our error bound. So what's that telling us? That's telling us that our 8 trapezoids are going to be, the most they're off is 4.7. Well, that's off quite a bit, right? Well, but look what our K2 value is. It's a great big value, which means what? It's really curvy, right? That's the curviness, right? K2 is the curviness. It's the max of our F double prime. So we're assuming a lot of curviness in this graph. So that means the trapezoids are going to be off quite a bit, right? We'd expect that. Now, if we were doing the same problem and I didn't, and I said, how many trapezoids would it take, right? How many trapezoids would it take to be within 0.005? Let's say, how many trapezoids would we need to give us that degree of accuracy? Well, we'd have the same K2 value, right? So we do the K2 the same way, but now we just go in here and we do a solve. And so we do our solve, and so it would be a fraction, and it'd be 29.042 times 5 cubed, and then on the bottom, we'd have 12x squared, and then we want less than or equal to 0.005, and then comma, we're solving for x. And we'd ignore the negative, and so it's going to take 200, how many? We would say it's going to take 246 trapezoids. 246 trapezoids if we want to get 2 decimal place accuracy. So 8 trapezoids wasn't very good. So in this case, because it's got a lot of curviness, it's going to take quite a few trapezoids to give us that. So those are the 2 things you would do with it. You know how many trapezoids or lefts or whatever you're doing, and so you want to know how much error is that, or what's the max error. Or I might say, hey, we want the max error to be this. You tell me what error would have. Okay? All right. So that's the K1, K2 business. Okay. So those were the max error formulas. We had that stuff. We talked about orders method. So here are some problems. Some of these were homework problems you already did. Like today we did 11, 13, and 15 on 6.3. Here's 10 and 12. Okay, now I'm not saying I'm going to go around and check your homework tomorrow, but those, I just tried to pick out some problems from the homework. These were those true false ones about over approximating, under approximating, stuff like that. So go back and look at that. This was the 10, 11, 15 would be ones to practice the K1 and the K2. And those might be ones we already did on homework, but it doesn't matter. The point is these ones. I think 11 we did already. We didn't do 10. We didn't do 15. But those are just ones to practice the K1, K2 stuff.